Good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for this month's session on Big Data and Hadoop for the SQL Pro with Cindy Gross. I'm your host for this session, and my name's Warwick Rudd. Before I kick off to Cindy, I do have a couple of little housekeeping bits to run through. Some of you who were here last month may have heard about that we've got a new sponsor, SQL Sentry, and as such, over last month, this month, and next month, for all attendees that turn up to the DBA Fundamentals virtual chapter sessions, you do go in the draw for a professional edition of Plan Explorer. With when they're drawn, we'll be able to let you know who those lucky winners are. For next month, we've got Paul Randall talking to us about index fragmentation, internals analysis and solutions. That session is currently available for registration, so make sure you register, and I look forward to seeing you all next month. Before we continue, I just want to give a plug out to the SQL Saturdays coming up in Australia. So as you can see, early next year, we've got Melbourne and Sydney as back-to-back sessions. If you're in Melbourne or Sydney or you wish to travel, make sure that you sign up and register for those events, and you will get two fabulous days of learning from some very good presenters. So without further ado, I'll hand over to Cindy and we'll get this session rolling.
Hi everyone, thanks for coming, and we are here today to talk about big data, and I'm going to talk about it from the perspective of SQL Server. So I hope you all can see my screen.
You just need to accept
and
it.
I do encourage you to tweet as we go along, and you can tweet at SQL Cindy. And my blog is smallbitesofbigdata.com, and a lot of the content that I'm referring to here is on that blog as well. So I'm going to go ahead and get started here. And the first thing we're going to look at is SQL. So hopefully this looks very familiar to you.
Cindy,
just to select, yes.
Can you just accept being the presenter so that we can see your screen?
Yeah. Hold on. How's that?
That's better.
Oh, okay. All right. So, do you see my Visual Studio?
Yes, with your select statement.
Okay. Okay. Excellent. So, what we've got here is just a basic select statement, the same statement that you could run on a SQL server, but in this case, this statement actually happens to be running against Hadoop. And the reason I'm showing you this is because it's an easy entry point into the big data world. Quite often, you can cut and paste your SQL Server or your Oracle queries and put them directly into Hive, which is the component of Hadoop that makes data look like it has rows and columns in it, whether it has a structure that originally looked like that or not. So if you are able to run this Hive query, then what you would see in this case is we're pointing it at a flat file. And the flat file in this case is just comma-separated values. And it could be anything that we wanted here. We could load data that is in a very complex, highly nested JSON structure. We can have very simple CSV files. We can have files that have different structures and different ways of looking at the data. And that's generally when you hear about big data being for unstructured data, what you're usually talking about is the fact that you don't necessarily know ahead of time what the structure of the data is, and there are multiple ways you can apply that structure to the data as you go along. You don't have to define it ahead of time. And I'll show you a little bit more about what that means here. So you can see this is a create table statement. It looks very similar to what you would see in SQL Server, but it's also a little bit different. So you have your basic statement here where you say create table, you give it some columns and some data types. You tend to be a little bit more generic with your data types in big data because you don't know for sure what the data that's coming in is going to look like. So while I could go back and define this as a char 30 or something like that, the next time I had data that was, say, a char 35, it would not fit in here. And while that's a great thing to do in a relational world where you know your structure ahead of time, that's not so great in the big data world. So generally what you'll see are string and the more generic data types, and not try to narrow it down. You assume that your data was already entered and that you don't have any control over it. In this case, I'm also saying that I am going to choose my delimiter for my data, and in this case I chose commas. Now I could choose all sorts of different things here. I could say that I'm going to point to JSON, XML, any different format I can think of. There are some proprietary formats I'm not going to go into, but I'll just mention them. There's Parquet, there's ORC or optimized row columnar format, there's Avro, all of these different formats. And if you have your own custom format or your own way that you want to ingest the data as it comes in, you can create your own SERDI. SERDI is a serializer, deserializer, and you would just point to it here in this section with whatever format you want. And again, that goes back to the separation of schema and data, and that's what allows you to have what some people refer to as unstructured data. In this case, I'm pointing at a directory. As I add new files to this directory, my next query will pick up those files. And I'm just going to show you a little bit more complex query here. So again, this first one could be a cut and paste from SQL Server. The second one, though, is not something that you could do in SQL Server, partly because you don't have to. This is an optimization that has to do with the fact that all of your data in a Hadoop system or any other big data system is distributed out over many different slave nodes or child nodes, or you'll hear all sorts of terms for them, worker nodes, data nodes. And if you simply do an order by statement, what you're going to get is the work is spread out over all the nodes. Say it's spread out over 100 different nodes, and then at the end it has to come back to a single node to be ordered. In a Hive or another type of Hadoop statement, you can say distribute my tasks out so that it reads the data in grouping, so that, say, if it's grouped by score, in this case, all the scores of 1 to 10 go on the first node, all the scores of 11 to 20 go on the second node. So when we say it's very similar to SQL, it is, but on the other hand, you have to do a lot more manual optimizations here. So you can see here in Visual Studio, and there are many different ways to run the queries. I'm showing Visual Studio because hopefully it's familiar to you guys as SQL Server professionals. So here I've run a series of queries, some completed, some failed. I can go back and look at any one of these, and I can look at the job output, a couple of different ways that I can look at the different logs. So there is some rich functionality here to let you drill down from the query into the results that you would see. And just to give you an example of that, this is the output from that first, or actually it's the second, the query for more fun. And what this is going across that data that is scored, and it's saying, in the first case, my first query said return the score if it's a negative score, something I don't want to do. And then everything that I do want to do, I don't care what the score is, I just want it listed. So that's the output that we get there. And then I do want to show you, I'm not really going to talk about Pig very much, but when I talk about big data, quite often I'm going to refer to some variation of Hadoop or some other distributed processing system. And quite often, 80 to 90% of the time, it's probably going to be a Hive system. That's going to change over time as we get more SQL-like systems in, but Hive is the one that looks like rows and columns, looks like a SQL type of statement. But you also have the option to use something called Pig. Pig has a language called Grunt. It's a little bit less particular. Pigs will eat anything is the joke that Pig developers will tell you. It's more of a scripting language. So you can crunch a bunch of data through Pig, and if it runs across data that doesn't meet the data types you've defined, you can still continue on to the next row. Whereas Hive is finicky like a bee. If you say something's a string and it's not a string, then Hive will choke on it. But pigs will eat anything, so it'll be a little bit kinder with data that you don't understand ahead of time. So this is just showing you basically the same sort of query that I showed you earlier in Hive, and I'll go back and show you. This is a Hive query. This is an equivalent Pig query. And in this case, I could either have pointed to an existing Hive table, because Pig can use Hive tables as well, or just to show you a little bit more functionality, I showed you how you would define that data dynamically or apply the schema at runtime, as is more typically done in a Hadoop system. And again, the output here is pretty much the same as it was from the Hive query. Okay. So I'm going to switch back over to the slides now. And again, just to show you that this is SQL. It's the same sort of concept where you're going after the data in a way that makes sense to most of your business users. So when you start using Hadoop via Hive, you have a very easy entry point into the system. And again, it's not completely the same because it's much more dynamic in terms of how you define the structure over the data. Generally, you'll load your data ahead of time, and at the end, you will create one or more structures on top of that data. And one thing that's interesting that you can do in Hadoop that you cannot do in a SQL Server system is build actual tables, not just views, but tables, more than one of them across the same data set, and you do that by just giving different names but pointing to the same location. And again, it's a mix of familiar and unfamiliar because some of the syntax is the same. It's like going from T-SQL to PL/SQL to MySQL's variation. This is HiveQL or HQL, and it's just another variation of the language with some optimizations for the distributed processing environment. One thing I didn't show you in Visual Studio is that you do have the option of getting a little bit of a GUI view of what went on in the system. Now, this is nowhere nearly as rich as the show plan or any of the visual outputs for SQL Server that you have in Query Analyzer, SQL Server Management Studio. But it is something that is fairly new in the Hadoop world. And that's one of the themes you're going to see over and over is that the rich enterprise functionality that you're used to seeing in SQL Server is starting to come online in some of these big data systems like Hadoop. So let me just flip back over real quick to one other thing that, you'll want to take a look at, which is the fact that Hive and Spark, for that matter, that we're going to see in a little bit, have ODBC drivers. So therefore, I can go into something like Tableau or Data Mirror or Power BI or any of the common BI tools that are out there. And I can simply say, I want to point to my Hadoop cluster in the cloud, and I want to connect to Hive using the account that I've set up. And from that point on, it's just another data source. Now, you do have some differences in terms of latency. So when I do something that is the equivalent of an index seek, it's probably going to be faster in SQL Server. If I do something that's the equivalent of a table scan and I have enough nodes behind it, it's probably going to be faster in Hadoop. So given those constraints, it really is just another data source. Another thing, though, that makes it a little bit different, I keep contradicting myself there for a reason, it's the same, but it's different. It's different because you now have a richer set of data sources and you have data that may not have been fully curated and cleansed by IT. So either IT or a business user can load whatever data they want, quickly iterate through various sets of data. So maybe you want to pull in some weather data to combine with data you have already, and you try data from NOAA for the US, or you try data from some other public data set until you find the one that has the data that you need in the format that you need it. It's very easy to rapidly iterate through that in a Hadoop or other distributed processing system environment, much easier than it is in a traditional relational system. So that would be another difference, and something that you might see with your end users, that they come out with reports or various things that they've tried and set up that use data that you don't even have any control over, and now you have to go back and figure out how to integrate that into your system. So again, it's the same, but it's not the same. And lovely, we got an error. I think it's because I didn't go back and set the password on that one. Regardless, that's just a way to show you that this is an ODBC data source, and that is actually reading the same data that we saw from Visual Studio. So that's Hive. very quick overview of one of the most popular systems in the big data world. And I know I have not yet really told you what big data is, and that's on purpose. I wanted to just give you a little intro of seeing something real and seeing exactly what is out there and how much it does look like a SQL Server system. And now that I've gone on and on about Hive, the new open source shiny object that everybody is so interested about is Spark. And Spark lets you do, again, SQL-like queries. SQL or Spark SQL is a way to get very interactive, whereas Hive is never going to run a query in less than 20 to 30 seconds because of the way it has to distribute the optimization or optimize the job across multiple nodes. You're going to see that Spark can return results instantly. However, Spark is brand new. It's something everybody's interested in, something that everybody wants to use to query their distributed or semi-structured data, but it is still brand new out there. And let's just take a quick look at Spark. So this, I'll show you this interactively in a second. This would be an example of what Spark looks like when you actually go to use it. So how did I get there? I created a cluster and I chose the type of Spark, and I'll show you how to do that in a little bit. So what I've got now is a Hadoop cluster. I happen to name it Spark, but it could have any name that I want. And you can see here that I've got a couple different ways I can view this. So I can come over here and see the dashboard. I can see all the different settings that I could change in Spark. This is much easier in a cloud-based system such as HDInsight. It's also easier on Amazon as well. I mean, it's not specific to us. It's a cloud thing. So you've got the ability to change all of your configuration settings. You can look at the various notebooks that are available and have been created. In the Spark world, things tend to be done in notebooks, and I have an example here of a Zeppelin notebook. Data scientists love these because they can tell a story. These are actually called paragraphs, so you could have text in here, you could have all sorts of things. So a data scientist might set this up as, hey, I'm going to go out and do this thing, and then I tried this thing, and I tried something else. So it's very interactive. It's like a series of windows in Management Studio that just go in a linear fashion down the screen. So notebooks are very popular with Spark. And you can see in this case what I've done is I've pointed to a file or a directory. I know that it's a little bit small here. See if I can make it bigger. And it's the same file I was using from Hive. And so what I'm going to do now is say, take that data, and again I'm going to say it's comma delimited. It's just different syntax to do that. I'm going to go ahead and define it here as having some data types again. And then I'm going to say, all right, I've got all my definitions for what I want my data to look like. Again, this is similar to creating a table in SQL Server. And now I'm going to actually run my SQL query. And again, this is much faster than Hive because I have a really small cluster here. I think it's just one node. It took almost a full second to run. And one thing that's really cool here in these notebooks is I wrote this query and I did not have to do any additional code to come in and look at these different visualizations. That's just included by default with the notebook. And again, I could have multiple paragraphs out here. So in this case, I have another one that is just doing a slightly different query over that same data. And again, I can visualize it however I want. I can choose to change the various settings. You know, I could look around until I find whatever visualization I like, and now I can turn around and productionalize it like I could with any other system. And in this case, I am doing SQL, but you can also do Python, Scala. You can do machine learning using various machine learning libraries. There's a graph database available in Spark, and there's streaming available in Spark. So there are all these different ways that you can interact with it. And one thing I do want to show you here is when I go to create the cluster, I can choose various types. So in this case, I happen to choose it's a Hadoop cluster on Linux. And then I came over here and I said, I want a number of worker nodes. So let's say we're going to start with 4 worker nodes, and I'm going to change the size of them. And if I wanted to go down to an A3 for the worker nodes, I can do that, and I can immediately see right here on the screen the price I'm going to be charged for the existence of this cluster. And that's the charge, whether the cluster is completely busy or whether it's sitting idle in this case. And you can see also how many cores I have available left in my quota for my subscription. I can change that with an email saying, yes, I'm willing to pay for more cores. So just wanted to show you that. Once I have a cluster that's, or let me just show you here real quick, you can see there are different types of HDInsight or Hadoop clusters available. There's a plain vanilla one. There's HBase, which is the vanilla Hadoop plus HBase optimized with all the memory given to HBase. Storm, again, very similar. It's optimized for Storm, and Spark is optimized again with all the memory given to Spark. But you could also run Pig and Hive. Something that's really interesting here is that I could have one set of data. I load my data once up into Azure Blobs or in the data lake store that I'm going to talk about in a little bit. I load my data once. I could create a Hadoop cluster and a Spark cluster and a Storm cluster, all pointing to that same data. Each one of those clusters could be optimized and secured and billed back completely separately, and they could all point at that same data. I would only have to load it once. And that's available in the cloud, either in Azure or in Amazon. So let's flip back over to the deck here. I do want to point out that Power BI and Tableau, quite a few of the other tools have native Spark connectors, and again, Spark and Hive both have ODBC drivers. And really this is all about having more choices. So why do you as SQL Server people care? Because somebody in your organization is going to your CIO and saying, we should be doing something. We should be doing Spark. That's the cool new shiny object right now. Or we should be doing Hadoop. And they're going to catch the CIO's attention with things like articles from CIO magazine that say 15% return on investment from using big data. Now, of course, there are all sorts of caveats and context around that that aren't being shared. So you as a SQL Server person are going to either need to know enough about Hadoop and Spark and some of the other big data technologies to understand when that's the appropriate technology, or this other person that's going out and just making these bold claims is going to get all the cool projects, or they're going to start infringing on your SQL servers. And what you'll usually end up with in an environment where you've truly gone through a good process to figure out what needs to be done, you're going to keep your SQL servers and you're going to add Hadoop or other distributed processing systems on top of that or sitting next to them, and they're going to feed each other. So for example, what you might do is have this really fast ingestion method directly into one of the Hadoop systems through one of the streaming technologies, for example, such as Storm. And as the data lands, say it's Twitter feeds, and you want to immediately react to those Twitter feeds with a dashboard or auto replies or something like that, you can do that very easily in Hadoop without ever changing your SQL Server system. You're not replacing anything. And then you can take the analysis of those tweets and say once every 5 minutes load that data back to SQL Server, and then at the end of every day you could run reports against your SQL Server that say, all right, we had 1,000 positive tweets and 5 negative tweets, or whatever it is that you want to roll up for the day or the month. And again, you can go back and feed things back the other way. So maybe you keep the most recent 3 months in SQL Server on your very expensive storage with your relatively expensive SQL Server. Everything older than 3 months rolls back into Hadoop, and now you can do those analyses that go over the last year or the last 10 years or the last 20 years, not with Twitter obviously, but with other data. And that is in less expensive storage with compute that is elastic and can be spun up only once a day or once a quarter or whenever you need it. One thing I do want to point out is the real-time nature of things. So I mentioned Storm, and I kind of glossed over what that is. There's Storm is an open source tool, Azure Stream Analytics, Spark Streaming. These are all ways to push data through a query. So for example, you can say, every 1 minute, give me the average temperature on my assembly line for the last 5 minutes. So that's called windowing. And what you do here is you're looking for anomalies in the data. You might say when the average temperature goes above 100 degrees, or when I have more than 3 instances in the last 1 minute where the temperature went over 100 degrees, I want something to happen. I want some code to be executed. I want somebody to be paged, whatever it might be. You're looking for anomalies in the data, or you're aggregating data as it comes through. So those are real-time uses of the technology, and those are much more easily done in the new distributed systems than they are in a traditional system. I touched on the fail-fast methodology, so that would be the ability to go in and look at your data. You've got all this rich data in your data warehouse environment, whether that's SQL Server or something else, and what you can do is say, all right, I've got this data. Is my set of sales data going to combine with anything? Well, let's try mixing it up with weather data. Let's try mixing it up with pet ownership. Let's try mixing it up with movie releases, whatever it might be. And you can quickly iterate through those data sets and figure out, are they going to be worthwhile? And you might find, for example, that movie attendance affects sales of your particular product. And so then what you would do is say, all right, we know that if I sample 5% of the data, I was getting pretty much the same results as if I loaded the full data set. And I know I only needed these 5 columns, and I know that this one data source was the best. Now you turn around and productionalize that into a system such as SQL Server. So again, you've got an and situation. You have SQL Server sitting next to a Hadoop system. So, and I already talked about the latency and the fact that sometimes it's going to be faster in Hadoop, sometimes it's going to be slower than Hadoop, sometimes it's going to be the same. And a lot of times you can think of it as the art of the possible. So it may not matter whether it's faster or not. It may matter whether you can even do it at all. If you have a box on-prem that has, 2 terabytes of RAM, and that machine cannot be replaced, it would take you 3 years to get budget approved to be able to replace that system and plan for a migration, and yet you need to process something that is 100 terabytes of data, and you need it fast in a way that would require all that data to be loaded into memory. You just can't do that on SQL Server. I'm not saying SQL Server can't do it. You can't do it on the box you have sitting in your data center right now. Then what you can do is load that into Hadoop. You could load that into a blob store. You could stand up Spark on top of it and see what you can do. You could stand up Hadoop and Hive on top of it and see what you could do. So again, it enables new uses or makes things possible, and you just have to change your latency expectations or how you measure how useful a process or a set of data is. So if you guys want to type in some of the answers to these questions, I'll come back to this a little bit later. I am curious how many people have used big data, how many people have used the cloud, what sorts of questions you have. So if you want to type that in the chat window, we can come back to those later. And I'm going to run through an example, a real world use case of how people are using big data. And in this case, what we've got is a game development studio, and they need to see what happens when players are interacting online. In their case, they chose HDInsight, which is Microsoft's Hadoop implementation, and they were using Hive and Pig in particular out of that system. And again, Hive is what looks like rows and columns. It looks like a data warehouse, and Pig is a scripting language. And those sit inside open source Hadoop. HDInsight is Hortonworks data platform, or Hortonworks HDP. So it is open source Hadoop. They also chose Data Factory, which I'll show you a little bit later. They use SQL Server on-prem because that can connect back to all these other systems, Power View and Power Query. And in this case, what they did was they wanted to look at what caused people to stay in the game longer, buy things in the game, all those sorts of things. So they tried different things. They actually started out with an assumption that it was how many weapons you picked up in the game. And it turned out not to be true. It's how many people you interacted with. So that's an example of a fast fail terminal or methodology where they were able to try several things very quickly. And so what they did was in HDInsight, oh, and they also use Storm. So Storm, again, is that streaming technology that lets you push data through a query. They use Service Bus and they use SQL Server. And this is a typical telemetry scenario. So it doesn't matter what your telemetry is. It can be applied to a wide variety of things where you want to find out what's going on. What are your customers doing? What are your machines doing? What are your devices like cars or wearables doing? In this case, they looked at how players interacted, how long they stayed in the game, whether they used the tutorial, things like that. And this is just another view of the same thing here. It was every day, tens of gigabytes. So very quickly added up to terabytes of data. And they saved and moved that data about in various ways. And in their case, they used a 32-node cluster only 4 hours a day. So that's enabled in the cloud. Hadoop on-prem does not allow you to do that. In the cloud, what you do is you load your data, you store it up in the cloud, and then you build one or more clusters pointing to that data as you need it. So they're only paying for 4 hours of compute every day. And then at the end of each processing cycle, they extract some of that data and send it back to their SQL Server on-prem, and they do their typical reporting that they have the rich infrastructure built around. So just imagine what sort of use cases you can have. It doesn't matter what your business is. There is some question that your business cannot currently answer. And if you cannot currently answer a question that could change your business, you might be able to do that now through data-driven insights and tools that allow you to do distributed processing. Again, it's about making the impossible possible. And impossible does not necessarily mean not doable, because it's, you know, I'm a SQL MCM, I get it, SQL is this powerful thing out there, but it can be expensive. It can be hard to get through the politics and the licensing and the procurement process for getting things set up in SQL Server. Big data in the cloud lets you skip a lot of those steps, try things out, iterate quickly, fail fast, explore your data. And you can store all your data now, and you can change the compute that you put on top of it as much as you want. And one thing I want to point out, everything I've said, and particularly the next two slides, it depends, and it's only mostly true. First of all, most of what's on the next two slides applies mostly to the first one or two projects you do with big data, and they apply mostly to Hive. It is nearly impossible to talk about Hadoop and say one thing that is always true, because Hadoop is really just a loose collection of related technologies, most of which are scale-out solutions. Again, they're making something possible that was not possible before. So, when you're working on your first Hadoop project, you want to look for something that is data exploration. You want to look for something that's going to change your business with new insights that you can actually take action on. So I'm sure a lot of you have heard about a major trucking delivery company that now only makes right-hand turns. And they did that because they were able to analyze time to delivery and gas expenditures and figure out that by only turning right, they actually saved a lot of money. That's a big data example. Now, that's not a question that maybe they ever thought to ask in the old system, or maybe they did and it was dismissed as too difficult, but in a Hadoop system, they were able to answer that question. If you're going to rapidly iterate through a bunch of unknown unknowns, you don't know what questions you're going to ask yet. You just have a bunch of data and you know there's something in there. You know there's something you want to go after. You know there's some insight you're looking for, but you're not sure exactly what it is. That's when Hadoop or one of the other scale-out technologies can be really wonderful. If you already know that where you place a product on the shelf matters, analysis services can solve that problem really well. But if you don't know if the color of a shirt somebody wears when they walk into the store impacts sales, or if the weather outside impacts sales, or if what's on TV tonight impacts sales, those are all unknown unknowns. You don't know what you don't know. So it's much easier to explore those things in Hadoop. Again, flexible scaling. So you saw when I was showing you how to create those clusters that you can choose the number of nodes. You can scale that up and down. There's a slider bar for HDInsight that lets you choose 2 nodes right now. Then you can scale it up to 100 nodes. You can scale it up to 1,000 nodes and then back down to 2. And you're only paying for however much compute you need at the time. One thing we haven't talked about yet is Azure Data Lake Analytics. It has a different way of scaling the data. When you submit your job, you choose how many resources you're willing to pay for, and it does that at the job level. But the point here is that it enables the scaling due to that distributed processing. And again, it's not to say that SQL Server couldn't handle it, but it's very hard to write an application that scales out or even easily scales up on SQL Server. You have to change your code on a really big machine versus a small machine. You definitely have to change your code if you try to scale it out across multiple instances. Another thing about most of the distributed processing systems, they're usually good for a smaller number of concurrent queries that are being executed, which not always, but quite often translates to the number of users. If I have 5,000 users actively hitting a system, SQL Server can handle that no problem if you have enough resources behind it. A Hadoop system or any of the distributed processing systems, they were for the most part designed with batch processing in mind. They're designed for data scientists. They're designed for 5 people or 10 people, in some cases maybe 100 people. This is one of the things that is rapidly changing. I cannot tell you what is the number of concurrent queries or concurrent users you have on there. Somebody's going to come along and say, sure, we can support 5,000 people on a Hadoop cluster. I'm sure it's possible. But in general, if you're looking for guidelines on when to choose a product, I would not start out with my first product on Hadoop or my first project on Hadoop having a large number of users. And another thing that Hadoop is really good at is low-cost data archiving and data processing, data cleansing. So it's sometimes referred to as an ELT process. And the only thing many people use it for is just push that data through, cleanse it, dump it somewhere, and worry about processing it later, or only pull it back out end of quarter, end of year, or you don't know yet when you're going to use it. Those are all really great first projects. However, some really bad projects would be if you're trying to replace an existing system and the existing system is failing for something that I didn't mention in the previous slide. If you have an OLTP system and it's performing good enough and somebody thinks it's cheaper to do it in Hadoop, that's a huge red flag. If it's performing good enough on your current SQL Server system, it probably does not have the strengths, or Hadoop probably doesn't have the strengths to solve those problems. And I think that's a very important reason for all of you to learn Hadoop and the other distributed processing technologies, because people will try to do this. They will try to replace your existing transaction processing systems with Hadoop, and it's quite often not the right solution. And again, I'm not saying you cannot do that. I would not choose it for my first project. You want your first project to be a big success. You want it to be doing something new, not replacing something that people love. If you have a static schema, it's already well defined in a relational system, leave it where it's at. If you have interactive response time requirements, again, this is becoming less true, but something like Spark SQL is one of the few things that can actually, sorry. Sorry about that. Spark SQL is one of the, give me just a second. Okay, hopefully the coughing fit's over. So, again, if it's your first Hadoop project, just stay away from the mission-critical systems. And I do have these last 2 slides in a blog post on the smallbitesofbigdata.com. So, I know that you can't really answer back here, but hopefully at this point you have some thoughts about what big data is and is not. And one thing I have not explicitly said is big data has nothing to do with size or volume. So again, mostly true, and it depends. The driver behind a lot of the creation of these systems was volume, but you don't have to have a large volume of data in order to get good use out of a distributed processing system. I think we've covered what Hadoop is. It's one of the more common distributed processing systems, or one of the more common big data systems. It's a loose collection of various technologies. We'll see more about that in a minute. And as far as specific scenarios, just think about anything that you can't answer right now. Some new analytics type question, some new huge batch processing, whatever it might be. Try to think about how there's an unanswered business question that could be solved with data that you either aren't collecting, you aren't keeping enough of, or you can't process fast enough. So this is an example of some of the components that are in Hadoop. You can see it's just a huge array of technologies. You've got MapReduce, Taze, Pig, Hive, HBase, Phoenix, Storm, Solar, Spark, Elasticsearch, Scoop, Flume, Kafka, HDFS, Web HDFS, Falcon, Atlas, blah, 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 right? Don't worry about it. What you need to know is Hive. You're a SQL Server person, you're used to T-SQL. Hive, really easy to use. Spark SQL, really easy to use. The rest of them are interesting. Start with something that matches your existing skill set. And that's the easiest way to get in and make sense out of the system. And I do want to point out here Cortana Analytics Suite. So the reason that matters is, let me unpack that for a second here. You've got a whole bunch of technologies sitting up in Azure. The ones that are on this slide are, for the most part, the ones we've built. They're managed services of various sorts. There are open source equivalents of most of these. So for example, Azure Data Factory is an orchestration tool. There's something in the Hadoop world called Uzi. There's Azure Event Hub. There's something in the open source world called Kafka. Azure Data Lake Store, that's built on top of HDFS, which is a Hadoop storage system. There's Azure HDInsight, which is a open source Hadoop. It's Apache Hadoop. There's no difference in our Hadoop and anybody else's. So what you see here is a collection of managed services. Most of them have an open source equivalent, and you could choose one or both of them at any point. You could choose, for example, to use Kafka for some things and Event Hub for other things, even though they sit in the same space. However, if you use a managed service, your barrier to entry is usually lower because you have to do less of the infrastructure, the learnings, all of those things around it. And then we wrap that up for you in something called Cortana Analytics. So they're starting to push out packages. If you have certain healthcare needs, or if your business is built around some particular vertical, they're starting to push out these packages that are Cortana Analytics packages that do a lot of this work for you. So again, I've thrown out a bunch of huge, scary terms. You can do it the hard way, and in some cases you do have to do it the hard way, or there are also starting to be more and more really easy ways to do the same things, as long as they're doing distributed processing data. So we've talked a lot about Hadoop because that was the original distributed processing technology. I did, however, mention that in Azure we have some managed services, so I want to pivot back over to that. So on-prem, Hadoop is pretty much your choice. Now Spark can sit inside a Hadoop cluster, or Spark can sit independently of a Hadoop cluster, but logically just kind of think of it as the same as a Hadoop cluster for this discussion. So on-prem, you would have all of these different components, whichever ones you want to install. You could also install all of that in the cloud. It doesn't have to be on-prem. It can be on the cloud. It could be on VMs in the cloud. You can build your own. You can build them from our marketplace, or you can use a managed service like HDInsight. Or you can use one of the newer technologies. So there's the Data Lake Store, which is a Hadoop distributed file system enabled storage method, and it sits up in Azure Storage. You load your data through a single account, and it has what they call virtually infinite scale. You create your account once. You don't have to worry about saying, I want X amount of storage. As you add more data, it just goes right up there and allocates you more and more and more, however much you're willing to pay for, because that's why we're here. And then on top of that, you can put various computes. So you could put a Hadoop cluster like HDInsight. You can put something called Azure Data Lake Analytics. And that Azure Data Lake Analytics is another, it uses a part of the Hadoop system, but not the complete system. It uses the part called Yarn, or yet another resource negotiator. And that is what enables the distributed processing in the system. And this is another look at that. So again, you have HDInsight, or a managed Hadoop cluster, and it can have as many data nodes as you want. You can dynamically scale. You can start with 1 node. You can go to 100 nodes, 1,000 nodes, whatever you want. You can have multiple clusters pointing to the same data that's stored down here in blob storage or Azure Data Lake Store. And this is all built back and managed at the cluster level. Or you can go in and say, I want to write something called USQL that I'll talk about very, very briefly. And USQL is a mix of T-SQL and C#. And you could say, I want to write USQL, and it is going to go against the same data, and I'm going to be billed at the job level. So you give up a little bit of control over the environment, and in return you get a rich .NET plus T-SQL experience of the code, and that USQL code can actually also query out not just the Azure Data Lake Analytics service, but HDInsight and SQL Server as well. So again, a bewildering array of choices, but that's okay. You can start with Hive. So let's take a quick look over here at Azure Data Lake. So if I want to create a data lake store, I can go in here and say new store. And again, I only have to have one because I don't have to worry about manually scaling across multiple accounts like I would on a Azure Blob Storage, which is limited to only 500 terabytes. So here I could put as many petabytes of data as I want, and it's optimized for analytics storage. And I'm going to come over here and say I need to manage various settings. I need to upload data, for example. You can see that it's the I've uploaded the same file that I was using in my other test. And the thing that is new for storage in Azure is this ability to do role-based access control. So I can go in here and I can say that I want to make someone have only read access, and as long as they're somewhere in the Azure Active Directory that I have available to my subscription, then I could add them as a user on the system. And then the Azure Data Lake Analytics that I mentioned, again, I could come in here, I could add a new analytics account. Right now I'm showing you a subscription that's not mine, that's not signed up in the preview, so that you can see if you simply want to get into the preview for Azure Data Lake, you can just go here and choose, make sure you're on the right subscription, and then choose to sign up for the preview. All right, so let's go back to the slides. And this is a screenshot of the Data Lake Analytics. So this is Matt Winkler's cluster where he's run a whole bunch of jobs that I didn't have available. So this is a more interesting slide that I have on my account. So here you can see how many jobs have been running, how many succeeded, how many failed, how many compute hours have been available, and then this is or how many compute hours have been used that you've been charged for. And then I can also see over here, this is the USQL. So it looks very familiar in that it's T-SQL, but it has a lot of C# functionality added in that enables things that are not available in a typical T-SQL syntax. And then this is Data Factory. So again, I can just show you that really quickly. If I want to orchestrate an entire workflow of multiple things happening, I can do that in a data factory. So in this particular data factory, I can say, look for data in this directory. I believe it's set up to do it once an hour. And when new data lands in that directory or on my schedule that I've defined, I'm going to create an HDInsight cluster. And I think, there we go. I'm going to create an HDInsight cluster and run a Hive job, and we can see here that the Hive job, if I can get through all the blades, is creating a bunch of tables, running some queries, so it could be whatever I want. So the point here is that I could orchestrate whatever workflow I want. I could say, read this data, cleanse it using Pig and Hive, push it out to blob stores, push some of it into a SQL Server, run a bunch of SQL Server queries, extract that data out to a comma-separated file in a blob store, and then send an email to someone that their Excel files are ready. Those comma-separated files have now become Excel, and then I want to drop my HDInsight cluster or shrink the size of it or whatever it might be. So that would be a typical data flow that you would do in a data factory. So Azure takes your big data systems, it lets you go straight to the business code. You can do all sorts of interesting things because big data enables the separation of schema and data, and then the cloud enables that separation of storage and compute. So you can scale them separately, build them separately, secure them separately, whatever it might be. We have open source, we have Linux, we have both managed and unmanaged services. So if you want the fully managed Azure Stream Analytics, we've got that as a service. If you want Storm as an open source streaming service, we've got that as well via HDInsight, or you can spin it up on your own in Azure VMs. You can do hybrid systems, and of course you can still do SQL Server because a relational system is a key part of most big data systems. And again, what you're going to do here is put your data in a single location. In a data lake is the generic term in the industry. Gartner or Forrester refer to data lakes, taking over the world pretty soon. All your data streams into a lake. We happen to have a product called Azure Data Lake, which has both storage layers and compute layers. And then once the data is in that lake, you can stand up multiple computes on top of it. So if you decide that HDInsight with Hive is the best way, however you define best, to do some portion of your process, and then you decide that Azure Data Lake Analytics is the best way to do another part, that's fine. You stand up both computes on top of that single storage, and you run them both. And that might get you cheaper processing, it might get you faster processing, it might let you use existing data, existing skill sets, whatever you want to use as your criteria to define best. You can do that. So now it's no longer, do I want SQL or Oracle? The question is, how many different computes am I going to stand up? Instead of saying SQL can do everything or Oracle can do everything, and now I've made that investment for the next 20 years, now what you're going to say is SQL's really, really good at spatial data types and certain types of query optimizations for sub-second response time. Great, I'm going to use it for that. And Hive is really good at batch processing over petabytes of data. Great, I'm going to use Hive for that. And I'm going to use Storm for streaming new data into both of those systems. And you can do all of that side by side, and that's the new way that processing is happening. And hopefully this is all fun, and it should be something that is fairly easy to pick up if you start with Hive or Spark SQL. So, are there any questions?
Cindy, from the question list that you put out earlier, it was more of a comment about this is more of a gathering information and learning, but no real questions at this time around it. But if people online have any questions at all, feel free. We've got time. Shoot your questions through, and while we're in the questions, I'm just going to launch a poll also. So that you should be able to ask through any questions. We'll keep this open, and if you can answer this poll, this just helps us to track where everyone's coming from listening for the session today. Now, one of the questions that did come through was around the slide deck. The slide deck will be available for download from the DBA Fundamentals website. The recording of this session will also be available on the DBA Fundamentals website. After this session has completed, it will be created and posted up. So in the next day or two, both of those resources should be available for you to come back and review after this session. So I've got a good response on people. 60% have voted. Anybody else going to add to it? Okay. Okay, Cindy, can you recommend some books or training sites?
There are just a plethora of books out there now, which is very different than when I was starting to learn this a few years ago. O'Reilly has a really good selection of books on just about every topic. So the Definitive Guide to Hadoop, the 4th edition, is out. Depending on which technology you want to use, there's the Definitive Guide to HBase, I guess it's Programming Hive, there's Learning Spark. So O'Reilly is a great source. If you want to just get started right now with tutorials, there are a couple of different paths I can recommend. One would be if you search on getting started with HDInsight, you'll actually get a page that comes up that has a flow chart of different things you can do. How to create a cluster, how to manage cost on a cluster, how to run a Hive query, how to run a pig script, how to start with Spark. That's one way. Or you can start with a particular technology and look for HDInsight in that technology. Another thing you can do is go to the Hortonworks site. Cloudera and MapR also have great training. I say Hortonworks because that is where the HDInsight code comes from. Now, Hortonworks, Cloudera, and MapR are all using the same open source code from Apache, but we do use the packaged up version from Hortonworks inside HDInsight. So if you go to the Hortonworks site and look at their tutorial page, you can run a lot of those queries as well. Most of their examples use something called HUE, H-U-E, or the Hadoop User Experience. That's only available in the Linux version of HDInsight, not in the Windows version right now, and you do have to do one additional manual step to enable that in Linux. And again, if you search on HDInsight and HUE, H-U-E, you can find how to install that when you create your cluster, and then the Hortonworks tutorial should work for you as well. So those are some very good entry points. And if you have any questions, you can tweet to SQL Cindy. I'll do my best to answer them online. Email me, cgross@microsoft.com. Take a look on my blog, smallbitesofbigdata.com. There are quite a few really good blogs out there. The Big Data Support Team for Microsoft has some good blogs. Denny Lee has some really good blogs. Carl Nolan. There's quite a few MSDN articles out there that are written by our HDInsight team and our product team, so those are all good places to get started.
Okay, so Cindy.
Any other questions?
Yep, I've got a two-part, but so how big is the least big to start trying big data? Essentially, we are still a few hundred gig. Can we try big data with that size?
A few hundred gig for a first project is actually probably pretty large. Most people are probably starting with tens of gig for their first project just because it's easy to manage, to try things out. You'll see once you start running MapReduce or Taze jobs, which Hive and Pig both generate either MapReduce or Taze, that every time you run a query, just your spin-up time can be 20 seconds to 60 seconds. So if you're going against 10 gigabytes or 20 gigabytes of data, it's just going to be easier to do your first project. If you try to do hundreds of gigabytes or hundreds of terabytes for your first project, or at least the initial stage of it, you're probably going to run into problems. And again, it's not about the size of your data, it's about data that is bigger than bigger or moving faster or not definable, like unstructured, heavily nested JSON, for example, that's hard to do for some reason or too complex to do in your current system. It might be, literally 1 gig, but if you can't process it in your current system for some reason, cost, performance, ownership of the system, politics, it's a good candidate for big data. Just understand that your time to insight can be faster. Your time for an individual query might be faster or slower depending on what you're trying to do. So tens of gigabytes is actually a good size.
Okay, thank you, Cindy. Anybody else? Okay, so what programming skill levels are needed other than SQL?
What programming skill levels are needed? It depends on what you're trying to do, of course. First of all, let me say that somewhere around 80 to 90% of all jobs run against a Hadoop system are Hive. So if you can write SQL, you can do most of what you need to do. What you will find is that Hive and Pig are missing some basic functions. For example, there are some date time functions. Quite often what you can do is go find those. Datafoo, for example, has a huge collection of pig functions, or there's something called the piggy bank that has pig functions in it. You can find those for Hive and Pig. You can find various SERDES, serializers, deserializers out there. So even if something can't be done in Hive or Pig, which are higher level languages, quite often you can find a rich ecosystem of open source code that you can pull in instead. If that doesn't work, then you'll have to use Python, Java, or C# or F# or Java to write a function. And in some cases, you'll have to write the MapReducer, the TAs yourself. If you're doing a project like that, generally if you have somebody that's really good at Java or good at Python, those are the skill sets you need. But again, most of the time you need SQL skills. You need something that is a higher level language.
Okay, so we've got another one. Is it possible to build a test Hadoop cluster at home using desktop computers?
Yes, absolutely. You can go to the Hortonworks site and download the Sandbox, and the Sandbox is a virtual machine that comes in either Hyper-V, VMware, or VirtualBox, and that's a single node Hadoop cluster. There's also one in the marketplace for Azure, which I forgot to show you the marketplace earlier. But if you just go to portal.azure.com and click on the marketplace and search on Hadoop, one of the things that comes up will be the Hortonworks Sandbox single node cluster, and you can install either on-prem or in the cloud. And then once you do that, you can run the tutorials that exist on the Hortonworks site.
Okay, looks like last question for the session, but given that what we've covered off, what do you see or know is the future of SQL Server analysis services in comparison with big data, if any?
So analysis services is interesting. It does multidimensional really, really well. In the Hadoop world, we don't really have a great way of doing aggregations and cubes. So there are various products out there. AtScale is very popular. It puts what look like cubes in the system. There's Jethro data. There are various column store types of systems that can sort of do what a multidimensional system does, but none of them are really as good as analysis services at what it really specializes in. But analysis services does not scale all that well. So as long as you have something that fits in a single box in analysis services, it's great. You can use all the rich functionality of either the MDX or the tabular model, but as soon as you need to scale out, even though you might lose some functionality, you're going to have to move over to a Hadoop system. So again, it's not necessarily an either or. It's a question of how can you split up this polyglot of tasks into a polyglot of compute. So what you end up with is maybe you pre-process a bunch of data, pre-aggregate it, load those aggregations into analysis services. There's a case study out there that Denny Lee did with Yahoo. There's another one with Clout, K-L-O-U-T, where they did something very similar. They pre-aggregated the data in Hadoop. Once they had it aggregated, they shoved it into an analysis services instance and let it do what it's really good at doing. So really don't think of this as either or one thing replacing another. Think of it as a new world where you find a task. Instead of looking at the whole project in one system, you look at a task, and for every task you find the right compute, and for a given project or a given data flow you might have 3 or 5 or 10 or 20 different computes stood up along the way, each doing what they're really good at doing.
Okay, so one more has come through, Cindy. Do you foresee Hadoop becoming a must-have tool at most companies the way relational databases are today?
Is Hadoop a must-have tool? That's a really good question. And it goes back to the polyglot question as well, or my polyglot answer, I guess. So if you want to be able to do things very flexibly and kind of in some ways Wild West or off the grid, Hadoop is probably already in your system. Somebody out there likes playing in the Wild West and not talking to anyone else and sitting in a corner and doing their own thing with nobody else around. Somebody in your company is probably already doing Hadoop. Now, is it going to be essential for every business? It's a little unclear right now. So the concept of pick a single system like SQL Server and put everything on it has splintered into this, one store, multiple computes. What's going to happen in the future? Is it going to start coming back together? Are you going to start seeing that you no longer need Hive and Pig and all these other things? Spark's trying to do that. Spark's trying to say, we're a single system and we can do all of these other things. It's the shiny new object. It might make it, it might not. SQL, Oracle, Teradata, Pivotal, they're all out there trying to figure out how they can do everything. So if your company moves really slow and you're willing to wait 3 years or 5 years or 10 years, that question is going to get answered. Are we going to continue to splinter into many different products, or are we going to consolidate on one? And is that one going to be a variation of Hadoop? Is it going to be a variation of Spark? Is it going to be a variation of SQL or one of the other relational systems? Good question. But right now, today, it's the polyglot. It's the many different computes standing up next to each other, and no matter where we're going to be in a few years, somebody in your company is out there doing Hadoop. Go out and learn enough that you can defend your turf, that you can make the right choices on which data flows need to go through some other system before or after they come through your SQL Server. So hopefully that answered your question as much as a non-answer can.
Very good. Okay, on that note, thank you very much, Cindy, for your time and taking us through big data. Thank you to everybody who came along to this session. Remember to register for next month's session, and I look forward to seeing you all again next month. Thank you very much.
Thank you, everyone.